This is Cosmographia, the Randall Carlson podcast. Putting things into a chronostratigraphic context and causing havoc in the uniformitarian paradigm. We are back with Cosmographia podcast. You like that, Randall? I saw the. We're only here for the eyebrows.
I can live with it for the time being.
All right.
I'll put forth a valiant effort.
So it's been what are we at? A month since we recorded. We did some conferences. We had other stuff going on. So
we did. We're finally all back at our home bases for the time being.
That's right.
For number 14.
For episode 14. So before we get back into the megafauna, I had one question that has to deal with the Atlantis stuff, and I just want to. This is something I've wondered for a while. Like, so the geologists who were basically saying, that there is no geological evidence for any that Atlantis could be in the Atlantic, right? Mm-hmm. Are they wrong, or are they lying? Because those are two different things.
Yeah, no, I don't think they're lying. I think that they're so constrained within their vision by the dogmas that they've built their ideology around that they just can't see it. It's
okay.
It's too accepted by mainstream academia that Atlantis had no literal or historical reality behind it. And so once you've assumed that, and that becomes your working model of history, and it is now like guilty by association because there's been so much woo around the whole Atlantis thing that it just becomes easier, I think, to just not deal with it, because there's no reason that any geologists in their professional work would even have to address the idea of Atlantis. So it's been totally left up to the fringe researchers, which essentially has led to what I think is a lot of tangents. And that's why what I thought, when I first read Plato, which I guess, mid-70s, and then read and then reread and then probably reread again and again and again, maybe half a dozen times at least 3 or 4 translations. What it led me to think was, well, when you get past all the woo, there's nothing here that's so incredible that it's completely out of the question. Other than how your vision of what the civilization may have been. But as I've repeatedly said, I'm not going beyond the idea of simply a, Mycenaean or Minoan or Phoenician model, but maybe grander than that, but maybe not. Maybe just because the Minoan civilization in itself was pretty impressive, and their maritime skills were quite advanced. So we don't really have to go beyond that. I'm not saying that we should never go beyond that in our thinking as to what a Pleistocene culture, an Ice Age culture may have been able to achieve. But at the same time, there's nothing that I've pointed out or said in any of this that proves number one, proves the existence of Atlantis, but basically says that if you just take Plato at face value, there's nothing really that outlandish about it.
Right.
It's not so extreme and not so fringe that there could have been a culture on an island in the mid-Atlantic, because we've seen that there is evidence that there were islands much more extensive than there is today during the Ice Age. And we covered the multiple reasons for that and the evidence for massive vertical movement. So that was the whole point there, I think, is that we just go back and see if it makes sense. And what I've been trying to get at is basically saying, no, we haven't proven that Atlantis is there. Maybe that could happen or maybe not, we don't know what's down there, because unless maybe the U.S. Navy has information that we don't know, because they have done bathymetric surveys of the Atlantic Ocean. But the thing is, if you're not looking for something,
you're never going to find it.
You're not going to find it, right? And when you look at archaeological remains, oftentimes like the ruins of old buildings, oftentimes are difficult to differentiate from natural, natural rock. If you're looking at buildings that have crumbled, like say fallen in an earthquake, and they've been laying there for 2,000 or 3,000 or 4,000 years, and nature's already beginning to reclaim. If we look at something that's 10,000 or 15,000 years old, and it's basically something that's been reduced to rubble, and in this case, not only reduced to rubble, but then subsided beneath the ocean. Well, I mean, if you're not looking for something, you might not see it.
Right.
So you'd have to go there specifically looking for something, and it would have to be fairly evident. So what I'm getting at is really all I'm trying to do is say that the idea of Atlantis is not so outrageous that it needs to be automatically dismissed, but that if you look at the details of Plato's account, there's really nothing that contradicts or rules out the details that he specifically describes in his two dialogues, which to me then says, okay, so then the whole thing hinges upon our assumptions about what could be happening culturally 12,000 to 14,000 to 15,000 years ago. And if we make the assumption that there was nothing beyond Stone Age nomadic type existence, well, then that basically rules it all out, despite the fact that the geography and the geology, the hydrology, the oceanography are consistent. If we have ruled out the possibility that there was a culture that, for example, could explore perhaps large regions of the Earth's surface, that could have had colonies, if we rule that out, then of course the whole Atlantis thing, there's no merit to it.
Right.
If we accept that as a possibility, though, then of course the whole thing becomes, much more feasible.
Right. But the response to the Ignatius Donnelly stuff, we talked about that. There was basically a person who was a geologist. I can't remember the names or anything, but they responded and said, look, there is no, two or three of his points were based on geology, and we can say that those are wrong. And so you don't think that person, you think that person was just wrong, not lying? Like they just didn't know the research, or do you think that they were aware and they were just...
No,
lying?
I don't. That was Dorothy Vitaliano. I don't think she was lying. I think she just didn't know. Because by the mid 70s, we didn't really know that much about the ocean floor.
Yeah.
So if I just saw something the other day about, what's his name, an oceanographer. I captured it because it was very interesting to me. And it was commenting about really how much we still had to learn.
Yeah. But some of those papers you were reading us were from the 50s. So done before.
Yes. So there was, yes. The evidence was already accumulating by the mid 70s and had been accumulating for a quarter century. That there could have been something more going on there. In terms of, what may have transpired. Lost my train of thought there.
No, that's all right. Yeah, the evidence had been accumulating, and so I was just surprised that a person who was a geologist who set out to look into the matter actually didn't look into the matter and just wrote a book saying, no, this is wrong.
Well, she was the editor of the book. There was 5 or 6, I think, contributors to it that looked at it from different angles.
Okay.
He was the one who pretty much addressed it from the geological point of view and said, if Ignatius Donnelly's 13 propositions, which, we should actually get into that. Since we're going to do, I think, one follow-up episode on Atlantis to address some of the questions and things that have come up, we could look at some of those other propositions of his that were thrown out on the assumption that the geology didn't work.
Right.
But if the geology does work, then I would say that some of his other propositions would warrant a more in-depth look.
Okay. Sounds good.
So we've been dealing with that particular that span of time when we've been talking about Atlantis of 11,600 years ago, give or take. I would say give or take a century. Okay, puts us within that framework. Okay, so in that span of time, we know that there is a meltwater pulse, which is usually called Meltwater Pulse 1b. It was preceded by Meltwater Pulse 1a, which was about 1,300 years earlier, or roughly 12,900 years ago. And these two meltwater pulses actually bracket the Younger Dryas. And I have a slide here, which I think I will go ahead and pull up. Let's see if I can grab it. And I think this is it right here.
Okay, we see it.
There it is. Now, this is a curve of sea level rise. And if we look at the bottom x-axis here, it's 0, which is basically now. And on the right-hand end of the x-axis is 18, which means 18,000 years ago. And up this right side, we're looking at solar insolation curves, which if it was the sun and the warming of the sun, the dashed line that you see here would have been the curve. In other words, you would have had a gradual increase in the amount of meltwater and then a gradual decrease, right? Over here is the estimated discharge rate in cubic kilometers per year. So you look at the top of the left-hand y-axis here, and you've got 15,000 cubic kilometers. Okay, so what we have here is we've got two meltwater pulses, Meltwater Pulse 1a, Meltwater Pulse 1b. Okay, so when this graph was done, back in the 80s, I have the exact date, I can put that up here at some point. There was a range, right? A range of dates. So Meltwater Pulse 1a ranged between these two spikes right here in the dating. Meltwater Pulse 1b ranged right in here. Now, since this, the graph has been refined, and it's been correlated with global extreme events of global warming. But the point is, if we go to 11.6 right here, we see the start of Meltwater Pulse 1b coming up like this. Here we're going back to you can see right at 13,000 years, there's Meltwater Pulse 1a. Some of the dates have pushed Meltwater Pulse 1a back to as far back as 14,600 years. There's a possibility that there were 3 meltwater pulses. We can get into discussing that at some point. But for now, the main thing to take away from this is that the melting of the ice and the contribution of that melting ice back into the ocean basins of the world was not defined by the smooth curve, as one would predict, but huge spasms of meltwater gushing into the ocean that have been identified now by these two spikes right here. If I go to the graph of climate change, let's go to this one, go to this version of it here. We're coming from the left. So basically what's happening is we're coming out of the depths of the ice age over here on the left. You see this 15,000 years ago, 10,000 years ago. The gray box here represents the YD, which is the Younger Dryas. So you see here roughly 12,800 to 11,600 years before present, right? So what you have here is you have this massive spike of warming right here that then jerks its way back down into this full depth of glacial cold, which marks the Younger Dryas. So this spike of warming right here looks like it correlates with Meltwater Pulse 1a. Then that interval between the two meltwater pulses, let's go back to here. The interval between those two, you can see that there's a huge spike of meltwater. Then the volume of meltwater diminishes dramatically and quickly right in here. And then there's the second spike of meltwater being introduced into the world's ocean basins right here. So the idea is that we've got spike number one here. Oops, sorry. Spike number one here. And you'll notice that this spike, which is a bit higher than this spike of warming right here. See, this is the warming at the end of the Younger Dryas, which was extremely rapid, but you'll notice it's not quite as severe as this one, right? Well, this more severe one then correlates with, with the larger of the two spikes, which would make sense, wouldn't it? And see, so here you're looking at almost 15,000 cubic kilometers of ice melting per year. It actually could have been much greater than that. So this is the Younger Dryas. This return to full glacial cold that lasted about 1,300 years was then followed by a second warming spike. And then over the next, what do you see here? 10,000, so about the next 1,500, 1,600 years, the planet continued to warm up out of the ice age. And then we got up into the warmth, the modern warmth, basically, which is represented by this graph. Notice where we're at right now. Here's your present global warming. Most of the Holocene, I have to report, was warmer than the present warming. Right. And only really the colder part of the Holocene was the Little Ice Age. We've discussed that the Little Ice Age may have been the coldest half millennium of the entire Holocene, basically. Now, if you go back here to the 8,200 years, there's a cooling event, a very rapid cooling event, lasted for 2 or 3 centuries, and then it was over, and then you had another rapid warming spell right here. This global warming right here, from the 8,200 year cooling up to this peak, it certainly was more severe than anything we've seen in the last century. And then you can see that the temperature fluctuates up and down. Then here's your Little Ice Age right here, and then the present global warming. So, but the thing I want the people to be looking at here, the listeners to be looking at here, is this Younger Dryas and how it correlates with these spikes of meltwater. And how that in turn, see this 11,600, that's Plato's date right there. I mean, that's it.
Right.
Which to me would be a signal like, hey, interesting, but mainstream academia doesn't even consider that. And if they do, it tends to be thought of as merely a coincidence and not something that might actually have significance. That he's describing an island in the ocean that subsided, right? And the date of that subsidence is within a century of one of the great meltwater pulses that of the terminal ice age. So
yeah, clearly a coincidence.
Clearly a coincidence.
Oh no, it's clearly a myth.
Yeah, it's also interesting that warming spike there that caused Meltwater Pulse 1A is not even as warm as most of the Holocene has been. That's also interesting. Right.
Yeah. What is the explanation for that? I don't know. Now, when we get to this cooling, yeah, and we're going to start looking at that in this episode. The evidence for an extraterrestrial type event here. What's going on here? I don't know.
Yeah.
It could be argued that it's the sun. Perhaps it is.
Right.
Perhaps it's a combination of things. You know, there's still so much to learn yet. That's why I get really annoyed when I hear somebody talking about the science is settled.
Right.
Because we're not even close to having it settled. Okay.
Not even
then
close.
here in the light of what we've been talking about in the last episode with the extinction of the megafauna, let's bring up this graph. This is the late Pleistocene mortality graph, which was published in the 80s. And each little block here represents the finding of a fossil, an extinct mammal that lived in the Pleistocene. We've got here radiocarbon years before present. So down here on the right, we're looking at, there's 4,000. So this last block here is right at 4,000 years old. Over here on the left end, we're 50,000 years old. the y-axis here gives you the number of dates, and there's black squares and white squares, and basically the difference is the accuracy with which they separated their finds into two categories. One, the black, which was very accurately dated, and then the white, which wasn't quite as accurately dated, right? So, but other than that, the curve is still obviously represented here. And you can see that you're going along for thousands and thousands of years, and there are sporadic introductions of megafaunal carcasses into the fossil record. But when you get right here at, say, here's 12,000, 13, 14,000 years, when you get right into that bracket between Meltwater Pulse 1A, Meltwater Pulse 1B, that correlation with the Younger Dryas, this is what happens. All of a sudden, hundreds of examples of fossils, extinct megafaunal fossils, show up. See, this is like, you could think of this as a mortality spike. And this mortality spike is pretty much perfectly bookended by the Younger Dryas.
So that the y-axis there says number of dates, but does that mean like the number of samples, basically? How many of them?
Yes.
Okay,
yes.
Yeah. Number
so
of
if
dates.
we look at this one here, we come across, that is 45. That's 50 dates there.
Right. So 50 times they were dating fossils they found there. So you got 50 different samples.
Yeah. So 50 samples were dated and gave you this large spike right here.
Right. Whereas previous to that, we're at least leading almost all the way up to that, those two big spikes, everything was below 5 in number of samples. So
exactly. Yeah. And then all of a sudden you get to this terminal ice age, terminal Pleistocene, Holocene transition that coincides with the meltwater pulses, which coincides with the climate spikes, and right in that bracket is this.
Wow.
And then at the end of this, half the megafauna of the planet is gone. Zip.
Right.
So many of the individual animals decimated that there was no possibility of them reproducing, which basically means you have to ultimately, for a species to go extinct, you have to basically eliminate every single viable pair. Yeah.
Right. Yeah, and you have to do it in a single generation.
And you have to do it in a single generation.
Yeah, that's crazy.
Yeah. So I would say these three graphs correlate. Now, what's driving this? What we know, I would suggest that the mortality is a measure of something that's going on. And again, the mortality is going to be directly related to loss of habitat. Species loss can be directly correlated with habitat loss. Habitat loss is going to be directly correlated with what? Well, what is it that's going to basically eliminate habitats? Well, now is when we get into the various catastrophic scenarios. You know, what could, for example, destroy millions of acres of grassland that would have supported a megafauna, or millions of acres of forest that would have supported a foraging or a browsing megafauna, right? So these, you're basically losing habitat. And even in discussions of modern extinctions, that's what a lot of the extinctions would be ultimately blamed upon, is loss of habitat.
Right.
When we see extinctions on islands, that's where most of the modern extinctions of the last couple of hundred years have been on islands. And islands are a microcosm. And, you know, when you're talking about thresholds of processes that could lead to mass extinction episodes, in order to completely eliminate a species, one of the models is that there are various thresholds. Once those thresholds are breached, now the species is basically a lost cause. On islands, those thresholds are much lower. And most of the extinctions on islands were the result of the introduction of invasive species. But if you look at the spike of modern extinctions, you find that it's gone way down in the last few decades, actually. And we're going to do a series on extinctions in Earth history, because it's a very important thing to understand, especially because extinctions are now being brought into the political discussion.
Right. And it seems interesting to me too that, like, because it's hard to look and say like, well, what would you consider to be a constant level of extinction? We don't know that. How many animals are going extinct all the time anyway?
Well, yeah. If you look at the older ideas, it's pretty much at any given time, 10%, and it's kind of an arbitrary number. 10% of species are going extinct.
Going extinct at any given time.
10% of new species are evolving. And in that model, the evolution is being driven by natural selection.
Right.
And it's assumed that natural selection is a random process.
Sure. Yeah.
But if you question that today, then you suddenly get lumped in with fundamentalists and Bible thumpers and,
right.
There are some
6,000 years old.
yeah. And there are some, there are ways, methods, or I would say tactics of evasion, so that some of the questions don't have to be addressed, because that just complicates things. And like, if you don't need to complicate things just to do your government job or your industry job or whatever the case may be, or your job in academia, which is basically to promulgate a certain model of reality.
Yes.
So these three graphs are, to me, very interesting, and to look at these graphs and ultimately the question raised then is, clearly a warming or a cooling spike. I mean, we're looking at 10 degrees centigrade here, right? Which is about 18 degrees Fahrenheit. That is an enormous warming and an enormous cooling. These are massive fluctuations of the climate, right? So we need to be asking what's driving that. That's what we're looking for. That's, to me, the ultimate question is the trigger. Something, this is not just happening. Something is triggering this. So, okay, let's start talking some more about some of the interesting circumstances under which these fossils are found. That was one of the things that's always intrigued me. So I like to go back to old stuff, because a lot of times the old stuff can actually be pretty right on. I mean, see, here's the thing. At the beginning of geology, you had these guys going out there who are looking at the landscapes without any preconceptions, right? They're just seeing and reporting upon what they're seeing. Interestingly, when you look at what so many of the early geologists, and whether it was Cuvier or Buckland or Adam Sedgwick or Roderick Murchison, the list goes on, they all looked at the landscape and in their own way saw that there was the effects of catastrophic episodes in the history of the earth. Now, this is in the 1820s, 1830s, 1840s, 1850s, right? As we get closer to the 20th century is when uniformity becomes a dogma, primarily through the efforts of Charles Lyell, Playfair, James Hutton were the three that pretty much Hutton came up with the idea of uniformitarianism. Charles Lyell is the one who pretty much was able to introduce it as dogma into the newly established geological halls of academia that were consolidating and forming in the late 19th century. Does that make sense? So as they were, because in the 1820s to 1860s, 1870s, there was no formal geological science, right? It became formalized, say, between the 1870s and the 1900s. Becoming formalized as an academic discipline led to the establishment of dogmas, right? And one of the preeminent dogmas of geological science was the doctrine of uniformity. And so this is why when we get to the 1920s, J. Harlen Bretz had such a hard time getting his massive evidence for gigantic floods accepted by the geological community. That's why it took 30 years from the first publication of his papers. Really, the first one was about 1923, where he specifically invoked the idea of massive floods, right? And it was really not until the mid-60s that you see the geological community beginning to accept the idea. We will have future episodes that address where I think this whole understanding of megafloods has gotten to now. In my opinion, there was dogmas introduced into the models between the 50s and 60s. In other words, the academic community, the geological community accepted the reality of great floods, but did so only with a lot of strings attached to it and a lot of limitations that, in my opinion, were artificially imposed on the model of flood causation. And so I wanted to get into that in great detail, because some of the areas where I've been attacked has been people looking superficially at some of the things I've said or written about the mega floods, projected their own ideas of what they think I'm saying, which is not what I'm really saying, and then use that to try to discredit the things that I have said, that I really have said. So at some point, I would like to address that in more detail, because, what it's gotten down to now is the idea between one gigantic flood, at least in terms of the Pacific Northwestern floods, the so-called Missoula floods, or many, many, many floods, 40 to 90 floods, right? And we will examine those models and everything in between, and I will have a chance, I would like to anyway, have a chance to really get into what I think are the inconsistencies and the omissions within the standard model, which has been pretty much intact since the 1950s and 1960s, with some elaborations. And we get into all that. But interestingly, I look at those meltwater floods correlated with the meltwater pulses into the global ocean, which of course only makes sense, right? If you've got rapid rises of sea level, that because you've got 10 or 15 or maybe more, maybe 20,000 cubic kilometers of meltwater being introduced into the oceans, causing that rise. Well, obviously, yes, you've got enormous melting, and that enormous melting is going to be causing enormous floods. And what I think that they're missing is by looking at isolating regions and looking at those, when you look at the Missoula floods that created the Channel Scablands, you can look at them as a catastrophic event, cataclysmic, beyond anything we've experienced in modern times, yet still limited to the region. And what I'm saying is, no, if we put that box around it, we're not going to really understand the totality of the process, because we have to understand that these gigantic floods are issuing from all over the ice sheets, and they're actually even issuing from far up from 500 to 1,000 kilometers back from the margins of the ice sheet, which is not what we would expect from normal melting, which would be recession of the glacier margin back, you see. So yeah, and also that those floods, the timing of those floods, I want to look at that in terms of these three graphs that we just looked at. Also the fact that I would say 85 to 90% of the fossilized remains that are being found are found in depositional environments that are most readily and accurately explained as flood deposition.
Okay.
Yeah.
That makes sense.
You're damn right it makes sense. Okay, so now this is a Jeremiah Van Rensselaer, maybe Rensselaer, I don't know. Maybe it's a Jeremiah Van Rensselaer, MD. He wrote this in 1826, right? Now, just because it's written in 1826 doesn't mean that it has no diagnostic value, okay? So let's settle that right now. Somebody's going to get under there. He's quoting stuff from way back, like because somebody observed something 200 years ago, that observation has no value or validity anymore, right?
Right. Let's throw out everything Newton said then, right?
Yeah. Let's throw out everything that Newton said, and Galileo and Kepler and Copernicus. Yeah, right.
Yeah. Well, one of the arguments I've heard on that front is well, we have better technology and our methods are better now, and
Well, of course.
Say to that.
Right. But ultimately, all science begins with observation, and the most fundamental observational process of all is this right here, our own eyes. Everything else is just an extension of that.
That's right.
So here's what Jeremiah Van Rensselaer, MD, wrote in the American Journal of Science, 1826. And the title of his report is the notice of a recent discovery of the fossil remains of the Mastodon. He says, during a jaunt made last month in company with Dr. Decay and Mr. William Cooper to the tertiary region of New Jersey, we had the good fortune to disinter and to bring to the city the skeleton, nearly entire, of a mastodon or mammoth, as it is colloquially but improperly termed. About 3 miles west of the watering place is situated the farm of Poplar, occupied by Mr. William Croxon, Esquire, and owned by his father, who nearly 6 years ago began to reclaim a marsh about a quarter of a mile from the house. A marsh would be a low area. Usually it will be very boggy. There will be peat deposits typically in a marsh. Sometimes they can be very thick, right? This marsh was usually covered by about 2 feet of water. The water was easily drained off. When the moisture having evaporated and the earth particles consolidated, the surface sunk very gradually between 2 and 3 feet below its former level. Last year, in crossing this field formed by the reclaimed marsh, the attention of the proprietor was attracted by something sticking out of the ground. A lot of these finds are somebody seeing something sticking out of the ground, which proved to be a tooth. He then searched a little and found part of the head of a large animal, partially exposed, being covered by grass only. Mr. Croxon had the kindness to conduct us to the spot, where we soon found sufficient inducement to dig, and in short time our hopes were fully realized and our most sanguine expectations surpassed. In the course of that and the following day, we recovered all the bones of the skeleton that Mr. C had left. It is to be observed that our skeleton was found much nearer to the ocean than any yet discovered, and is perhaps to be considered as one of the most perfect that we possess of that immense animal. The bones near the surface of the field and within the influence of frost have all suffered more or less, but as we proceeded down, they became more sound, and the bones of the legs and the feet are perfectly solid and in excellent preservation. Its position, corresponding with that of the skeleton recently found on the Wabash, was vertical, the feet resting on a stratum of sand and gravel. How do you get a skeleton preserved vertical?
Right.
That's amazing.
Yeah.
Yes. Then we'll
They have
go.
to be buried while they're standing up, basically. Yeah.
Yeah. Then we'll go to the year 1952, right? In the Ohio Journal of Science was a report. And here's what it says. In November of 1949, some workmen at Orleton Farms, which is in Madison County, Ohio, were probing with an iron rod to locate a plugged drain tile. Striking a hard object, they made an excavation, finding instead of a tile, a large mammal bone. The manager of the farms notified members of the staff of the Ohio State Museum, who identified the specimen as that of the mastodon, Mammoth americanum. Arrangements were made to excavate the site. Excavation showed that the bones were lying on and in a layer of limey clay or marl, about 1 foot in thickness, which extended to a depth of about 3 feet. The marl lies upon the glacial till. Above the marl layer is a layer of black muck or peaty material, peaty material about 2 feet in depth. Now again, so what we have here is kind of a low basin environment, kind of a marsh, right? just very similar to the finding that we were just looking at from 1826. The remains of this mammoth are found in there, buried near the surface, right? So it turns out, then, going on here, that the skeleton proved to be badly disturbed and the bones crushed and broken. As an example of the amount of disturbance, one of the ribs lay beneath one of the tusks, while another was thrust through an aperture in the pelvis. A shoulder blade rested to the right of the skull, and one of the large neck vertebrae was found about 10 feet from the skull, near a portion of the pelvis. In spite of the wide dislocation of the parts, the bones of one of the feet remained intact and in place in the spot where the animal last stepped. Even the largest of the bones, such as the thigh bones, were broken squarely across, indicating that some considerable force had been exerted upon them. Any conclusion as to an agency powerful enough to cause such destruction must be highly speculative. So you got to picture this. How would you accomplish that? Well, basically, you could get something very similar to that effect if you had a gigantic hammer, and as this mastodon is ambling across the land, this hammer comes down and crushes him flat, snapping the huge femurs, which I'm going to show you a picture here. We're going to do a screen share.
There's a few behind Brad, too.
Yeah, there's a mastodon behind Brad, exactly.
Perfect. So, yeah, crush that guy flat and spread bones all over the place. Yeah.
Yeah. Okay, here we go. So here's the pit. And
oh, this is the one you were just talking about.
This is the one I was just talking about. Yeah.
Orleton
So
Farm.
Here he is. He's cleaning off the skull, which is right there. And you can see some of the other bones right over here. They've got the pit roped off. And you see that's buried under, looks like a total of about 4 feet of material here. There's the femur right over there. That's the thigh bone. Okay, so here's the femur, and the arrow is pointing to a break right there where the femur has snapped. And you can see the size of that bone. I mean, it's 6 to 8 inches thick. So, interestingly, what do we attribute an incident like that? What force could crush a mastodon? And the question is whatever killed this mastodon, was it an isolated event? Or was the death of this mastodon part of a much larger event that was actually the extinction of the species? See, that's the question that I would ask at this point. In either case, the implications are rather interesting because we're faced with something here, just like the frozen Beresovka mammoth.
So are we talking about a big flying chunk of ice here after?
I don't know.
Yeah.
Yeah.
Nobody knows, I guess. But I'm trying to figure out what could be a giant hammer that wouldn't leave a crater.
I would leave a, let me see what I'm trying to say. I have my preferred explanation for how you do this, right? And we can certainly get into that. So let's go on here. The idea here is the overkill hypothesis. Paul Martin was I would say was the sort of the founder of the modern idea of the overkill hypothesis. Now, the overkill, also called the Blitzkrieg hypothesis, is the idea that ultimately the extinction of the megafauna is blamed upon human hunters. And Paul Martin was the primary proponent of that idea, going back to the 60s. Now, this idea had been around for decades, but what he did was in an era when nobody was really contemplating the extinction, the mass extinction. He brought the mass extinction into academic discussion, published papers on it. His conclusion was that it had to be humans because he couldn't visualize anything else. Like, for example, in this paper, co-authored by Paul Martin and H.E. Wright, which was published in 1967. It was at the 7th Congress of the International Association of Quaternary Research. Quaternary, of course, is the two geological epochs of the Pleistocene and the Holocene. Okay. The title of their paper was Pleistocene Extinctions, the Search for a Cause. So they wrote, Pleistocene geologists are not the only ones who have a good deal at stake in understanding what caused extinction at the end of the glacial period. If climatic change was responsible, then it must have been a change of a magnitude not known previously. Then they asked the rhetorical question, are meteorologists prepared to recognize the possibility of a climatic shock wave of unprecedented dimension within the last 15,000 years? Question mark. Well, their answer to that question was basically, no, they're not. We're not. The academic community is not ready to recognize the possibility of a climatic shock wave of unprecedented dimension. Not in 1967. They weren't. So in 1983, another paleontologist by the name of W. Jeffrey Spalding was looking at the overkill hypothesis. And he says the overkill hypothesis as a plausible explanation for the extinctions of the late Wisconsin megafauna. And this was published in the journal Quaternary Research, volume 20, page 110. The author at the time was with the Department of Botany and Quaternary Research Center at the University of Washington in Seattle. The overkill hypothesis attributes the extinction of late Pleistocene megafauna to predation by Upper Paleolithic big game hunters. Whatever their cause, terminal Wisconsin extinctions of mega mammals are of great interest to natural scientists. It can be argued that because of their timing, these extinctions represent a single event, and that because of its impact, it is the most drastic ecological catastrophe noted in the Quaternary record of the Western Hemisphere. Given that the Quaternary record at this point in 1987, I think it was considered to be about 2.5 million years, that means it's a pretty drastic extinction event. In North America alone, 34 genera of mega mammals. Now, genera is the next taxonomic level above species, right? So go species, then genera. In North America alone, 34 genera of mega mammals, including 7 families and 1 entire order, became extinct at the close of the Wisconsin being the name of the North American Ice Age. The number of latest glacial generic extinctions of large mammals exceeds the number of genera lost during the preceding 3 million years.
Wow.
Yeah. The overkill hypothesis is among the more radical and probably the most controversial of the proposed explanations of late Wisconsin megafauna extinctions. It is also the only one, get this, it is also the only one that approaches the requirements of a valid, testable hypothesis. It specifies the mechanism, timing, and specific effects of a discrete phenomenon. It accounts for the majority of the fossil data, and most importantly, some of its crucial aspects are falsifiable. I'll pause right there and I'll say it accounts for majority of the fossil data. I would say that that is completely an inaccurate statement. That the overkill hypothesis, human predation, it does not, I mean, just the two examples I just read. I don't think you can blame the death of the Orleton Farms mastodon on human predation. Unless humans killed the mastodon, it was laying there underground, and then something came along and crushed it, right? Yeah. What it comes down to was the crushing of that mastodon skeleton the same thing that caused its death? I would say, but his next statement, I totally agree with, that it is falsifiable. And I think since 87, when this was written, I think there's been enough evidence that's accumulated that totally contradicts the possibility that roving bands, small roving bands of nomadic hunters using spears, was able to cause the total extirpation of over 100 species of megafauna at the end of the last ice age. Two important dependent components of Martin's theory are, number one, megafauna extinction occurred abruptly, and it's at about 11,000 years ago in North America. Now, given that this is in the mid-'80s, that this dating, we've pushed that back now. So that you really need to add another millennium or two, because this is all based on radiocarbon dates. And the radiocarbon dates have been recalibrated since this was written. So this is actually going to be a millennium or more too young. So just bear that in mind. So number one, megafauna extinction occurred abruptly at about 11,000 years ago in North America. And two, the first colonization of the Western Hemisphere by Upper Paleolithic man was coeval with those extinctions. Now, notice the second assumption. The idea that the extinction occurred coeval, that's the term they use, of the first colonization of the Western Hemisphere by upper Paleolithic man. So that's one of the dependent, so there are these two dependent components of Martin's theory. So what happens then if we discover evidence that pushes the date of North American Paleo-Indians back 2,000, 3,000, 4,000 years? Well, now you don't have the correlation anymore between the mass extinction and the
arrival.
Colonization.
Yeah.
That goes away. And I think at this point, there's enough evidence in hand to say, clearly the Clovis were there 500 years before the extinction. Did they do it? Well, they probably got the blame. But as we showed, we see that the Clovis culture collapsed at the same time as the extinction.
Yeah.
So these are, as it said, these are the two important dependent components of this idea of overkill. That it occurred abruptly, right? Now that we're going to agree with. Yes, certainly in the geological sense, it occurred very abruptly. Even if it took 1,000 or 1,300 years or 2,000 years, it's still inexplicably abrupt. But we can actually show from things like that graph that I just showed you, the mortality graph, it looks like pretty much that massive mortality event all occurred within about 1,000 years. And maybe within that, because that graph is already 2.5 decades old. See, yeah. As we refine our dates, that graph may actually get narrower and more prominent.
Yep.
Yep. So then he finally goes on to say, and this is an important point too, at Cowboy Cave in the Canyonlands of southeastern Utah, a stratified deposit of bison dung terminates abruptly at about 11,000 years before present. The Cowboy Cave record suggests that as a biotic phenomena, the mechanism causing terminal Wisconsin extinction had an impact even on those genera that ultimately survived the event. And I brought up the example of the American bison, which was, I kind of did a little digging in and looking, and I think that what I found was that the nadir of the bison, North American bison population, there was right around 300 individuals, down from literally millions. Okay, so if the bison had, in fact, if the bison, those 300 individuals had been left to their own devices, they may have not survived. I mean, they actually course, the bison didn't. I don't think there were too many predators after after the extinction of the American Pleistocene lion and the giant short-faced bear and the saber-toothed cat. There may have not been predators that could take, maybe a pack of wolves could certainly take down a bison. But the point being is the species came very, very close to extinction. Now, if we were looking back from 10,000 years from now, we could totally miss the fact that the American bison came within a hair's breadth of extinction. So a lot of the species that did survive, the point here being, let's take the American moose. The American moose or reindeer. Reindeer existed during the late Pleistocene. Reindeer survived. But that's not to say that the total number of reindeer wasn't decimated by the same events, because think about it, it's logical. You can't just exterminate completely, half of the megafauna and then leave the other half completely untouched or unfazed. In the nature of these events, those other species had to have been affected as well. And that's his point here, that the mechanism causing terminal Wisconsin extinction had an impact even on those genera that ultimately survived the event. So.
And that was based on, was that in a cave?
Yeah, that was in a cave.
Yeah, so there was bison dung in a cave, and all of a sudden that deposition stops abruptly.
Yes.
And so like all the bison that were leaving that in the cave disappeared.
Yes.
Yeah. That's
yeah.
So
now here, this was an interesting debate that was going on in the pages of Science back in the journal Science back in 1962. An article by Harold E. Lippman, who was an independent researcher, who wrote in that the frozen mammoths was clearly an indication of some kind of a catastrophic event. And this appeared in the pages of Science back on August 10th, 1962. And it was a challenge by Harold Lippman and a response by William R. Farrand, who was at the time, you could say, an establishment academic geologist, right? So this is what Lippman was talking about. He was referring back to this sort of debate that had been taking place in the pages of the journal Science. He says, in an earlier issue of Science, William R. Farrand made a valiant attempt to salvage the gradualistic position vis-a-vis the frozen mammoths. But these fossils of the Siberian permafrost present an insuperable difficulty for a theory of slow, gradual geology. Baron Cuvier, one of the most critical observers of these remains, insisted that they were frozen suddenly. He wrote, "It is well known that its tusks are still so well preserved in cold countries that they are used for the same purpose as new ivory. And as we have before remarked, individuals have been found with the flesh, skin, and hair which had been frozen since the final catastrophe of the globe." End of quote by Baron Cuvier, who is considered one of the founding fathers of geology and paleontology. Now, William R. Farrand, defending the establishment point of view, responded to Lippman's challenge in the pages of Science and said this: "It is not," and this really represents the mindset, okay? "It is not logically sound to postulate a major catastrophe on a scale far beyond anything we have experienced to explain geological phenomena which can be adequately explained by the everyday processes which we can observe around us." So that was pretty much the idea right there. Sums it up. It's not logically sound to postulate something on a scale beyond what we have experienced and which can be adequately explained by the everyday processes. So that was pretty much epitomized the academic perspective on these ideas in 1962. And Harold Lippman would have been considered a crackpot. Pretty much.
They also, I want to say, they keep referring to them as fossils, but most of these aren't actually
right
fossilized, right? Yeah. Okay.
Yeah. So, what is the trigger? That's really what the question is. If there was if the trigger was not waves of barbaric Paleo-Indian hunters, obliterating everything before them so rapidly that these species, extinct species, couldn't even reproduce, then what was it? And was the Orleton Farms mastodon a clue? Now I'm going to go back here to the time of Thomas Jefferson. Are we allowed to do this? Because we're going back now to, the early 1800s.
Yeah, I don't know.
Back to 1780. Can we do that? If we do that, then that pretty much discredits everything, right?
Yeah, everything we say is discredited after that.
Everything we say is discredited after that, yeah. But you know what? We're going to do it anyway.
That's right.
All right, let's do it.
Let's do it. Can't discredit somebody who, well, yeah. I don't have any. You can't discredit me, so I'm not worried about it.
Oh, this was Jefferson writing about 1780 when he was governor of Virginia. Notes on Virginia, right? Anybody can go dig up Notes on Virginia, find this this account in those pages. And he says, our quadrupeds, big four-footed beasts, right? Four. Ped means foot, four-footed. Our quadrupeds have been mostly described by Linnaeus and Monsieur de Buffon. Of these, the mammoth, or big buffalo, as called by the Indians, must certainly have been the largest. A delegation of warriors from the Delaware tribe visited the governor of Virginia, and here he's referring to himself in the second person, during the Revolution on matters of business. After these had been discussed and settled in council, the governor asked them some questions relative to their country, and among others, what they knew or had heard of the animal whose bones were found at the salt licks of the Ohio. Their chief speaker immediately put himself into an attitude of oratory, and with a pomp suited to what he conceived the elevation of his subject, informed him that it was a tradition handed down from their fathers that in ancient times a herd of these tremendous animals came to the Big Bone Licks and began a universal destruction of the bear, deer, elk, buffaloes, and other animals which had been created for use of the Indian. And then the great man above, looking down and seeing this, became so enraged that he seized his lightning, descended on the earth, seated himself on a neighboring mountain on a rock of which his seat and the print of his feet are still to be seen, and hurled his bolts among them till the whole were slaughtered.
Wow.
So could that be a clue?
Yeah.
That's amazing.
Sounds like a lot of clues.
Yeah. So, yes.
Yeah, I mean, the imprint of where he sat
Right.
sounds like a crater.
Yeah.
That's great.
Yeah. Now,
Buffalo.
hurled his bolts among them. I know there's going to be those who immediately assume that that's supports the electric universe model.
Right.
I don't think we need to go there because, I mean, we're looking at evidence now that can actually be explained through the impact of a bolide or a piece of a comet nucleus much more effectively than a much more hypothetical model, because we're now actually confronted with the finding of the actual fingerprints
Right.
of that
Also,
kind of event.
Thunderbolt, the term Thunderbolt used to be used in reference to more than just lightning strikes also. So
Yeah. Although interestingly, certainly there is going to be electrical phenomena. Now, I'm not
Right.
going to rule that out. There was electrical phenomena associated with the Tunguska event,
Right.
right?
Well, you
And-
put enough dust into the atmosphere, there's going to be a lot of electrical phenomena going
That's
on.
right.
Exactly. So there's a lot more we could get into here.
We are
But
close to an hour.
yeah, we're up on time.
We
so.
may be at an hour.
okay, can we go another 10 minutes? Is that allowed?
I
I'm totally
guess.
down.
Well, is that okay with you, Mike?
Tell me more mammoth
Sure. Let's go to midnight, dude.
Oh gosh, it is almost midnight. Okay, so here's some more clues. When we see, so what I've been doing is going through the literature of the finding of these specimens and the circumstances under which they're found. Now, there's a term we're going to introduce here: taphonomy. Taphonomy is the study of what happens to a fossil specimen between the time it was a living organism and the time it becomes preserved in the fossil record. Now, there are multiple routes to get from living organism to fossil. Like you were pointing out, the processes involved in the preservation of the late Pleistocene mammalian fauna are not going to be the same thing that leads to the preservation, say, of an ammonite or a cephalopod from the Mesozoic, right?
Yeah.
But we still consider them, in a sense, fossils. The idea of taphonomy still applies. We're still interested in, okay, if we're talking about the mastodon, the Orleton Farms mastodon, it gets smashed into the ground. Well, to know the process by which it went from a living mastodon to the circumstances under which it was found, that is taphonomy.
Okay.
Right? That's taphonomy. So we're looking at the taphonomic circumstances in relation to the finding of these animals. Now, this is appeared in 1986 in a journal called the American Midlands Naturalist. Now, the thing is I have to, in finding this stuff, you have to not only go through the more accepted mainstream stuff, you have to also go off into the things that's outside the mainstream that, perhaps, mainstream academia is not necessarily going to be referencing the American Midlands Naturalist, because this is a regional journal, but it gives a report on findings that are germane to that particular region. So somebody studying what's going on in the Southwest or the Northeast might not be reading the American Midlands Naturalist, right? So anyways, we'll get into this. This is entitled Late Glacial Pollen and Macrofossils Associated with the Raccoon Mastodon in Lapeer County, Michigan, okay? Warren Whitry directed a systematic excavation of the site in 1965 and 1966 and recorded the location of all recovered fossils. The mastodon was an old male. Whitry stated, quote, "Now, the bones of the feet were widely scattered." And here's a key point. Many of them are charred in a manner which indicated that flesh and cartilage were present when burning took place. Some of the ribs, vertebrae, long bones, and the base of the skull were also charred in a way indicating that flesh was still present. The skull was 20 feet away from the place where it should have been. It lay upon its base on the surface of the glacial till. The plow, however, did not do all the damage to the skull. At least 3 large pieces of it had been removed prior to the plowing and were found in undisturbed earth 20 feet from the skull in the area of the left leg. So once again, we have the finding of a disarticulated skeleton, but now we have the addition of major charring that apparently was the result of a fire intense enough that it burned through the flesh, and charred the bones. So if we're going to try to understand this, I think we have to look at these events as part of a pattern and not assume, like the quote I read from the mainstream viewpoint, that the conditions under which these specimens are found can be readily explained by human hunting.
Right.
Yeah.
Yeah.
Can you say, I mean, could one say in general that fossils are typically created in a situation that's catastrophic?
Yeah.
I mean, most of the time, if something wanders off and just slowly dies in the woods, its bones end up getting scattered by scavengers and
Yes, that's a very good point. A very important point. Fossilization
It's
is not
extraordinary.
right. It's not the normal process.
Yeah.
It isn't the normal process. It requires rapid burial. It requires removal from oxygen, removal from forces that would recycle it, like you just said, scavengers. I have studies on modern elephant mortality that I've looked at in order to try to get a better perspective on the extinction of the late Pleistocene proboscideans. Well, what you find is that modern examples would be mass deaths of elephants at watering holes, dried up watering holes during periods of drought. Sub-Saharan Africa was subject to severe droughts in the 1980s, and several million mammoths succumbed to those droughts. Several million elephants succumbed to those droughts, right? And so you had water holes, that had numerous skeletons of elephants that had died there, right? Well, some of these paleontologists went and did taphonomic studies. And generally what they found was that in 5 or 6 or 7 years, those skeletons had been reprocessed.
Yeah.
They weren't there anymore.
Right.
They were gone. So, yeah, if you wanted to preserve those, you needed to bury them and bury them quickly. So, yeah, you're exactly right. Fossilization itself almost seems to suggest something out of the ordinary.
Right. So I wanted to read this too. I mean, this is just the definition of a fossil because I've always looked at it in terms of just like something that's turned to stone or whatever, but it just says a remnant or trace of an organism of a past geologic age, such as a skeleton or leaf imprint, embedded and preserved in the Earth's crust.
Okay, so it doesn't have to be stonified.
Right.
Petrified,
Right,
yeah.
right. It doesn't have to be mineralized. Yeah.
Right.
Yeah.
Yeah.
Every day, especially on this show.
Yep.
So here's an account of a mastodon unearthed in Sonora, Mexico. The account appeared in the Arizona Republic in May of 1998. It's entitled Village's Treasure. So deep in rural cow country on a dirt road connecting one farming village to another, history lay buried for more than 10,000 years. Beneath the packed brown dirt, under the route crossed daily by pickup trucks, cattle cars, horses, and herds, archaeologists recently unearthed the skeleton of a mastodon. Lying on its side, its more than 6-foot-long tusks spearing the embankment, the mastodon remains are being called a Mexican national treasure. In all of Mexico, northern Sonora has one of the richest deposits of fossil and historic artifacts. Petroglyphs and cave paintings are found across the state. In recent years, scientists have discovered fossilized remains of saber-toothed tigers, ancient turtles, and mammoths. But the discovery of a mastodon, which lived at the end of the Ice Age, is a significant find, said Ron Radkovich, a paleontologist with the Arizona Sonora Desert Museum in Tucson. To become a fossil, an animal has to be buried very quickly after dying and remain buried, Radkovich said. Scientists believe that the Cuvier mastodon died in a muddy bog and became covered with muck that protected the carcass from scavengers and the decaying effects of oxygen and weather. So you notice as we start going through this, we find that peat bogs, marshes, gravel pits. Now you picture that if an animal is caught up in a flood, if you look at the hydrodynamics of a flood event, what you see is as the flood finally dissipates, it will settle out in low spots, in basins, right? Material that is being conveyed within the currents then will accumulate in those low spots and in those basins. When you accumulate this, a lot of, say, organic material, if you have a great flood, it's going to sweep up earth, animals, trees, vegetation, right? So as this water settles in low spots, this will create the raw organic material that will metamorphose into peat. And also, we could go through the litany of findings, and over and over and over again, we find these specimens being found in gravel pits.
So I always thought it was strange how these things, you know, could basically be mummified in a bog that's wet, and you know, I always thought that was interesting. But I guess your point is that it's anaerobic. There's no oxygen, and that's
limited oxygen. And in the case of the, you know, these are skeletons now, so the flesh has apparently decayed away, the skin, the hair, right, for the most part, right? But the bones are still there. They are insulated enough from oxygen and from weathering and from scavengers that at least the bones can be preserved.
Yeah, and there are the bog bodies. Now they're not that old, but some of them are 6,000 years old, and
they
have
become mummified in a sense.
Mummified, yeah.
Crazy.
Yeah. So, so what we're getting at here, I guess, is you know, ultimately what we want to try to figure out here is, what is the trigger?
Fascinating.
I think we'll go on to talking about some of the associations between mammoths, and there are associations between extinct megafauna and hunters, no doubt. But it's a big leap to extrapolate from a few isolated examples of, for example, mammoth skeletons found with Clovis spear points embedded in their rib cage to that Paleo-Indian hunters exterminated the entire species.
Yeah. And it would be, you would seem to think that if they were killing all of these animals, then they should have plenty of sustenance. So why did their population bottleneck as well?
They all got fat. Too many mammoth burgers.
Well, you know, I read a Russian paper years ago where he actually did an analysis trying to figure out how much meat these Paleo-Indian hunters were going to have to consume in order to cause the extinction of the species.
Wow. We got to find that.
I'm sure I can find it. I've got it in my archives, but
it's also just ridiculously hard to believe that they also killed all the beavers and the horses and the all the other megafauna that died. It's just
right. And I think, if you confront them with that, what they'll generally say is because of the fact that the mammoths were a top tier species, once they went extinct, somehow it was able
percolated down,
the trickle down effect. Yeah.
Oh, wow.
So all right. So I guess we'll break from this one and resume in the next episode. And we'll get into discussing what could have ultimately been the cause, what was the trigger, what evidence exists now. And evidence does exist that begins to point in a very, very definite direction as to what the trigger may have been.
All right.
Great episode. All right, everybody can get a hold of us, the whole team here, at Cosmographia1618@gmail.com. Also check the website, cosmographia.com. There is a Patreon where you guys can support Randall and his work and this ongoing podcast. Many of you have done that already. Thank you guys so much for that. We really appreciate all the support.
We really do. We really appreciate that.
Support is growing, and it's really going to help out, and it already has begun to. So thank you guys so much. So that is patreon.com/Randall Carlson. Everything is posted on YouTube, at first at GeoCosmicRex, and then later on at Kosmographia channel, which now already has over 1,000 subscribers. So again, thank you guys so much.
Yep.
That really helps with the metrics, and also the ad revenue does bring in cash. So all of that helps. So we really appreciate that, all the support, all the comments. We all are reading the comments, so keep them coming. So
And we will be addressing some of the comments. Actually,
Right. That's
We
right.
really appreciate all of you who enjoy the show. And to the angry mob, thanks for watching.
That's right. Thanks for watching, guys. Really appreciate
I would add to, if you're going to ask a question or have a detailed commentary, to send it to that email address.
That's right.
Don't leave it to a Facebook page or, a group. Send it to the email so we can share it and we can all see it is the best place. So at the Cosmographia1618@gmail.com.
Right. And also, if you are a Patreon supporter, you can send us messages through Patreon, and those will definitely get looked at as well. So that's a good way to do it if you are on the Patreon support.
That's
And we
right.
are coming up with other things that we're going to do for people who are supporting. I know right now there's not anything in particular except there's early access, but we're coming up with ideas, guys. So we really appreciate you jumping in early before everything's worked out.
Thanks so much.
Yeah.
Very much appreciated.
No, I lost it. Well, great show, guys. Really appreciate it.
Randall
Always a
Show.
pleasure.
Yep. All right.
All right.
Yeah,
Till
it's
next
good,
week.
Good launching pad to get into what's going to come for many more episodes.
All right.
Good night.
everybody.
Good night.
Ciao.
good night.
Bam.
Okay,
Mike gone.
Okay, Mike's gone. We can
Disappear.
talk freely now.
Right, yes. Everyone can relax.
Mike,
Ah.
great guy.
Yeah.
This is Cosmographia, the Randall Carlson podcast.